Chapter 8, Linear Regression.
That was on our quiz.
What can you say? Three words to describe it. That confused me.
A linear model. There's going to be a bunch of definitions here. Is the equation of a straight line through a data set we can use the model to make predictions about our variables a predicted value call that y hat. It's a y with a little hat on top of it. Is an estimate made using a model, the observed value which is just called y, is the true value the variable takes on a residual is the difference between an observed value and what the model predicts. Residual is equal to y minus y hat. Or observed minus predicted. The line of best fit, is also called the least squares regression line. And is calculated based on the squared residual values and these are additional names for a linear model. regression to the mean. Because the correlation for any data set is almost never exactly 1 or -1. Each predicted y value tends to be closer to the mean than its associated x value.
Was Victoria Eilish in your class?
Yeah, we graduated together. We grew up together too. We were just all the time. We were at church here. Alright, for example, the relationship between house size X and price Y has a correlation of 0.77 if a house has a size that is 1.2 standard deviations above the mean. What do you expect to be true of its price? So in this case, take the standard deviation of X and multiply it by the correlation coefficient R to get the expected number of standard deviation for Y. So we know that X is 1.2 standard deviations above. We were told that. So there's, well, it's going to end up coming in later, I think, but the formula would be standard deviation times the R value. So it'll be 1.2 times 0.77, which is 0.92. So from that, we would say we would expect Y to be 0.92 standard deviations above the mean. Always check regression conditions. Before creating a regression model. And since you just had them on your quiz, what are they?
Strength, direction,
No.
I said quantitative, linear, and outliers.
I got that question.
I was like really debating between the two, and then I was like, you know, that's because in order to check it, you have to have all those
Yeah.
things. I really contemplated that for a while. I have no idea.
Quantitative data, I would say a straight enough scatter plot or mostly linear. Okay, it's just. And no extreme outliers. And like if there are, remove them, more or less. Calculating the regression line using summary statistics the regression equation takes the form of y hat is equal to b sub 0 plus b sub 1x, where y hat is the predicted value, b sub 0 is the y-intercept, and b1 is the slope.
Is that a 0 or?
Yeah. It just represents the initial. So then if you are provided the following summary statistics, R, which is the correlation coefficient, X bar, which is the mean of X, Y bar, which is the mean of Y, S sub X, which is the standard deviation for X, and S sub Y, which is the standard deviation of Y. We would first calculate the slope. So B1 is equal to R times S sub Y over S sub X. So remember, it's still like rise over run, Y over X when you're looking at standard deviation. And then we're just multiplying it by the correlation coefficient. And then we need to calculate the y-intercept. So B sub 0 is equal to y bar minus B sub 1 times x bar. So you'd have to have the slope first to be able to do that. All right, so then we're going to look at an example. Model, it's going to be a model to predict fat from protein. So the stuff that we're given is that R is equal to 0.83, X bar is equal to 17.2 grams, S sub X, the standard deviation of X, is equal to 14.0 grams, Y bar is equal to 23.5 grams, and S sub Y is equal to 16.4 grams. So we're looking for the regression model that we can write with that. So we're going to need to find our slope, find our y-intercept, and then write an equation to fit that. And I should note that this was also given to us, but X is protein, Y is fat. That'll be important in a minute. So all of that would have been given to you for this particular problem. So we first need to find our slope. So we're going to use the slope equation here. So B1 equals R, which is 0.83, times S sub Y over S sub X, so 16.4 over 14. And that's going to end up being 0.97 grams of fat per gram of protein. So that's our slope. Now we can find our y-intercept using that intercept formula here. So B sub 0 equals Y bar was 23.5 minus B1 was what we just found, 0.97, times X bar, which is 17.2. If you do that, you're going to get 6.8 grams of fat. So remember, we're finding the y-intercept. Y was fat, so that's why it's fat. So then the actual regression model, which is what it ultimately wants, so it wants it to look like, let me scroll up for a second. It wants it to look like this, okay? But instead of Y and X, we're going to actually use the words for what they stand for. So we're going to use fat for Y and protein for X. So the way we'll write it is fat hat, okay, because it's the Y hat thing. So fat with the little hat symbol over it, equals 6.8 plus 0.97 times protein. So that's following the form y hat equals B sub 0 plus B1 X bar. Or just X, not X bar. And something that you're always going to have to do is you should always be able to interpret slope and the y-intercept in context. So So basically in words, state what it means. So with what we've been given here, if we were going to do that, we should say for B1 is equal to 0.97 grams of fat per gram of protein. It should be stated something like, for every 1 gram increase in protein, we expect fat to increase by 0.97 grams. And then for our y-intercept, equal to 6.8 grams, we should say something like an item with 0 grams of protein would be expected to have 6.8 grams of fat. Now, just something to note here, this statement is often not accurate due to context. Okay, I mean, you can make the statement, but it doesn't always actually mean it's true. That part. Regression from data. Huh?
These are long
Yeah, I still have 2 more pages. This is the last thing we're going to write, though. We'll do the rest of it on Monday. If you have actual data, values, you will use the regression functions in your calculator to complete the regression model. So you would enter X as L1 and Y as L2. The list must be in order. So up until this point it hasn't really mattered, but they now have to be in order. And the same length. Otherwise your calculator is going to tell you there's a dimension problem. Then you need to check the scatter plot of L1 and L2 to verify the linear regression is appropriate. and we'll talk about how to actually put it in and everything, which we've kind of sort of done already. But anyways, we'll do that on Monday.